Now, unfortunately, the sine law is not the end-all, be-all of our laws. As I said before, that we have a sine law, cosine law, and a tangent law. We don't really do the tangent law; it's a lot less known. But the problem comes is if we have any kind of triangle, well, we're not going to always be given an angle and the side across from it. There may be cases, oh, well, when I say maybe, there will be cases where you're going to be given sides that you don't know anything else about. And that's going to become quite difficult. So what we need to do is, if we want to find out what this side is, we're going to have to use the cosine law, sorry. So we need to know the other two sides and the actual angle that's contained between these two angles, or in other words, the angle across from the unknown side. Of course, these two could be switched. We may not know this one, but we do know what this is. That's what we'll do on the back side. Oh no, I think that we solve for the side. Yeah, I solve for the side first, and then I solve for the angle. So here is our cosine law. You'll notice in here, it's a lot more convoluted. But at the same time, you can see this very first part looks identical to the Pythagorean theorem. The main reason is this last part simply helps to correct for non-right triangles. For those of you that have taken pre-calc, for example, we're able to know that the cosine of 90 is 0, which would make this entire part 0. So we'd be subtracting 0, which isn't going to change our Pythagorean theorem. Same time, if you just type in cosine of 90 into your calculator, you'll see that it's 0. So if we have a 90-degree angle, this part just becomes completely irrelevant. So really, if you're looking at all practicality's sake, this entire thing is the official Pythagorean theorem. The only difference is we don't need this last part if we have a 90-degree angle. So the big thing, though, is when we want to prove this cosine law, so basically prove that this is the law, it's a lot more convoluted than proving our sine law. And I have it labeled like this. So there's a few things that we need to look at. For example, this is our height. We have the knowledge that this would be our side A, this would be our side C. Yes, of course, we could have labeled this as our C, this is our B, but it still works out. Now, instead of us labeling this entire side as B, what we're going to do is we're actually going to call it an X and a Y. Of course, keeping in mind that this entire side is side B. So really, we can say that side B is whatever the X part is, adding whatever the Y part is. Then we'll do some manipulation of this and do some more work here. So the beautiful thing is, by drawing that line straight down, we have made two right triangles, which means we have actually two Pythagorean theorems to work with. We have the first one, that our c squared, actually, sorry, I'll use the same colors. Our c squared would equal our h squared plus x squared. At the same time, our a squared would equal the h squared adding the y squared. So we're going to do some manipulation and get our h's by itself. So that means I'm going to subtract off my x squared and subtract off the y squared. Now I'm just going to go to one color really. We have h squared equaling c squared, subtracting x squared, and our h squared also equaling a squared minus y squared. Beautiful thing here means if we have a squared equaling this and h squared equaling this, it means they must be equal to each other. We can do some manipulation. For example, we can then add our x squared over. I'm going to make a little bit of a rearrangement here. I'm just going to put my x squared in front of my y squared for alphabetical reasons. At the same time, it's going to deal with a few more things. For example, these two terms here, x squared subtract y squared, is a special type of factoring. It's a difference of squares because we have a square subtracting a square, which means x squared minus y squared would actually be x add y multiplied by x subtract y. Oh, but what does that mean? We have seen some x plus y before. We have an x plus y here. Well, x plus y is b. So wherever we see x plus y, we can write b. So that's b. But that's no fun. We got to do some more there. Well, what about if we did some more manipulation here? For example, in this equation here, what about if we got the x by itself? So what about if we subtracted the y? So what about if we said that x is b subtract y? Well, if x is b subtract y, we're going to plug that in for x. So we'd have c squared equaling a squared, adding b. The x is b subtract y. And then we still have to subtract another y. So let's simplify. I'm going to take this down to 2 steps of simplifying. Which means it's negative y and negative y is going to be negative 2y. And then I'm going to do some distribution. So c squared be a squared, adding b squared, minus 2by. Well, let's go one more thing. I know it's very convoluted, especially the cosine law. It's going one step at a time, using a whole bunch of different substitutions. But it does help us to say that, yeah, this formula is actually right. This angle, C. Well, we have y would be our adjacent side, and a would be that hypotenuse. So if by chance we were looking for the cosine of C, it would be our adjacent side, which is y, divided by a. Or, more specifically, solving for the y would be a multiplied by the cosine of C. Well, we have a y here, so let's use it in place of y. So c squared will be a squared adding b squared, subtracting 2b, the y is, I'll just use red, a cosine of c. And the last thing I like doing is just trying to write things alphabetically. The b and a, 2ab, multiplied by the cosine of c. And that is our formula. What's the purpose of all this? Well, it ties into our proofs. It ties back with strict deductive reasoning. We are just using fact, which means that is probably, this is probably a very similar way to how the cosine law was actually developed. Of course, if I changed any of these letters here, the cosine formula would probably just look a little bit different. For example, it might be b squared equaling a squared plus c squared, subtracting 2ac cosine of b, or a squared equaling b squared, adding c squared, subtracting 2bc, multiplied by the cosine of a. So whichever way I had labeled this, the formula may have come out a little bit differently. All three forms are perfectly acceptable. I traditionally stick with this one for the simple reason that this first part looks like the Pythagorean theorem. And it's just a lot more commonly known. But what you must know about the cosine law is that this side is across from this angle. You have to know that. So let's go into an example. We're going to determine the length CB to the nearest tenth of a meter. So we're going to solve for what is this. It says that angle A is 58 degrees. It says AC is 32 meters. And AB is 40 meters. So if C squared equals A squared, adding B squared, subtracting 2AB, multiplied by the cosine of C, let's plug in our information. This side right here is across from this angle. Well, if that's the side that we're trying to solve for, we're solving for A squared. Everything else that we know, well, it doesn't really matter what A or B is. Just like in the traditional Pythagorean theorem, it doesn't matter which leg you actually plug in for which letter. So just by practice, I usually go least to greatest, but you certainly do not have to. You can put the 40 squared and then 32 squared. Just as long as you identify that this angle is across from this side. So the angle across from our unknown side is the 58. The beautiful thing about scientific calculators is that you can have all of this type into your calculator in one step. You can take the 32 squared, adding the 40 squared, subtracting 2 multiplied by 32 multiplied by 40 multiplied by the cosine of 58 to give us 1,267.40668. That's a 6.84, and we can still solve for our A. So we take our square root. Please don't just type 1,267. Make sure you use the entire number, which means knowing how to use your answer button on your calculator. So by pressing second square root, I'm using the text instrument 30x2s. I can use my previous answer as long as it was in my calculator. 35 35.6. This one actually has a unit, so we're going to use 35.6 meters. So you have to make sure you also know how to use your calculator. There we go. That's not a bad number. Now, if we want to determine the angle measure of an oblique triangle, we have to know all three sides. So actually, I'm going to make this look nice. If I have a triangle, and I know what X, Y, and Z are, I can still use my sine or my cosine law to help calculate one of my angles. The only difference is we're just going to have to do some manipulation either before or after we plug in our values. Personally, I only give you this formula. I never give you the manipulated formula. You're old enough that you can manipulate an equation. But as an exercise, absolutely, we're going to manipulate it. We're going to practice how to manipulate an equation. So if we need to try and get the C by itself, we're going to have to try and get rid of everything that's not directly attached to it, which means I need to subtract my a squared and subtract my b squared from both sides. So I still want to get that C by itself. I'm then going to have to do some division. We're going to have to divide by the negative 2ab. So now my cosine of C will be the C squared, subtracting the a squared, subtracting b squared, divided by the negative 2ab. So to get the C by itself, I'm going to have to do some cosine inversing. So C will be the cosine inverse, C squared, subtracting a squared, subtracting b squared, over a negative 2ab. Of course, if we had converted everything over and we actually moved this one over, subtracted the c squared, the formula would look slightly different. It could also be a squared add b squared, subtracting the c squared, divided by a positive 2ab. And the only way that we get that one is just by adding that 2ab cosine c over, subtracting the c squared over, and then manipulating. Both ways, perfectly fine. So as an exercise, absolutely, what we're going to do is we're going to have this triangle with A being 10 feet, B being 16 feet, 19 feet, 6 inches, and C being 20 feet. Add in a couple different units. Because in Canada, absolutely, we're going to have to know each measurement system, at least to a comfortable extent. So that's our A, that's our B, and that's our C. Side A, well, that's 10. Side B, it's 19 feet, 6 inches, and side C is 20 feet. You'll notice that this is for sure not drawn to scale, but it doesn't matter. If we want to solve for each unknown angle, we're going to have to solve for one at a time. So if I want to solve for A first, I'm just going to write down the formula one more time. If I'm solving for this angle, I'm going to have to make sure that this side is actually in the appropriate spot in the formula. Now you may be asking, why did we solve for all this stuff before? Again, it's just because I want to show you the practice of how to use the formula and how to manipulate the formula with the numbers already in it. Of course, you should be old enough that you can do that, but it doesn't hurt to have extra practice. It doesn't matter which one we have in which. My general rule of thumb is I do go smallest to largest. But 19 feet 6 inches is not 19.6 feet. It's 19.5. Just like if I had said this was 19 feet 3 inches, that'd be 19.25. So you do have to be cautious at times. Ask yourself, what does the question actually ask you for, and how can you get it? So we're going to do some manipulation. For example, I know that this is 100. 19.5 squared, calculator should be on, is 380.25. So I'm going to subtract 380.25, 80.25, and I'm going to subtract 400 from both sides. So if I have 100 and subtracting 380.25 and subtracting 400, uh, 2 by 19.5 by 20 is negative 780. Cosine of our unknown angle. 100, subtracting that 380.25 and subtracting that 400, is a negative 680.25. So I want to divide by the negative 780 to get my cosine by itself. I know that this is going to come out to an ugly decimal, so I'm going to leave it as it is. I'm just going to leave it as, well, besides the fact that a negative and a negative is positive, I'm going to leave it as a positive 680.25 divided by 780. That's going to equal the cosine of our C. I'll just change that to a green C. And then I can cosine inverse so our cosine inverse 680.25 over 780. Again, making sure you're in degrees, not in radians. C would be 29.3 degrees. Or, I guess in this case, it's actually angle A. So here, we have 29.3 degrees. You're going to have to do the exact same thing again. Now, if by chance we want to just use the formula for this, so C being our C squared minusing our A squared minus B squared over negative 2AB. Oh, maybe I should actually have my proper cosine inverse in there. This side is across from this angle. So if this is our unknown side, or unknown angle, sorry, the 10 is going to have to go into here. So really, angle A is going to be the cosine inverse of 10 squared subtracting 20 squared subtracting 19.5 squared. divided by -2 multiplied by 20 multiplied by 19.5. If you type it into your calculator correctly, you may need to add an extra set of brackets around the numerator. And on my calculator, I do have to. But again, that familiarity comes with making sure that you are using your calculator properly. 20 by 19.5. Yeah, I'm still getting 29.3. So here's a question where I've manipulated the formula. This is one where I've used the manipulated formula. Again, as I said, I don't usually like giving this manipulated formula. I expect that you're able to manipulate this. Now, if you have to memorize it, great, but make sure you write down your formula. Because if you don't, things are going to get hairy. So if I want to solve for angle B, just in the interest of time, I'm going to use my formula again. So to solve for B, I'm going to have to make sure I have that 19.5 in this location. So nice. Cosine inverse, 19.5 squared, subtracting 10 squared, subtracting 20 squared. I mean, if you're not going to use this and make sure that you understand how to use your calculator, you are hurting yourself. If you are not going to use this opportunity, make sure that you fully understand, it is going to hurt you. Make sure that you understand. Make sure that whenever you're typing something into your calculator, it comes out right. For B would be 72.3. And finally, I know that C, yes, I could use the exact same formula and do it again. But my very last thing, I can get away with knowing that there's 180 degrees in a triangle. So 180, subtracting my 72.6, subtracting my 29.3. 78.1. Now take a look at this. The smallest angle is across from the smallest side. Our largest angle is across from the largest side. This angle that's in between is between, or has the side length that is in between our largest and our smallest. It still fits that same characteristic. Now, you can go have fun.